Alright guys, today we are going to be working on utilizing a digital spreadsheet, in this case Google Sheets, to do some data analysis for your wooden block measurements. So the first thing you're going to need to do is go to your little waffle deal here and then open up Sheets. Or you could go to your drive and you could open up Sheets that way if this doesn't pop up. So you need a new sheet and you're going to choose a blank sheet here. And you should already, at this point, you should have something that looks like this. Okay, you were supposed to measure all 33 blocks and measure them with dial calipers out to the thousandth of an inch, and you're supposed to place them in here like so. It's a good practice to name your files with your initials and then underscore a short description. So I'm going to put quality control. Alright, so if you don't know anything about digital spreadsheets, these are very useful for organizing pieces of data or analyzing numbers and data and stuff, and making your job easier in regards to those things. So each one of these rectangles is called a cell, and like this cell that I've just left clicked on is A1. This is B1. You know, this cell is going to be C5, so on, so on. So some of you guys have already numbered your blocks down the list like this. Let me show you why using a digital spreadsheet is good. A lot of you guys probably did 1 and then 2 and then clicked again and 3 and so on and so on. But what this does is there are a few tricks here. So if I type a 1 here and I grab the corner here and I left click and hold down and then drag, it will copy whatever number I have in there. Okay, I'm going to undo this. Okay, however, if I go in here and I tell it what I want to do, so I might say there's some different functions I could use. So I could do equal, and I could say, so here it's already guessing what I want to do. So equal A2, which is this cell, plus 1. Okay, that's exactly what I want to do. I didn't even have to type it in. So I want to add 1 to this, right? So when I do that, it automatically calculates it for me, right? So then I can take this and I can drag this down, and it'll auto do that. Now, what's cool is in Google Sheets you can just type in 2 here, and then it kind of guesses what you're doing between these. So you can highlight them, and then you can drag this down. Like I'll drag this down to 34, and it will auto fill those, which is nice. Saves you a lot of time, especially if you have a bunch of cells or a bunch of items. So you should, anyway, so that's a quick trick for you. The measurements you should have here, now I just made this data up. This isn't good data. Everybody's data from their blocks is going to be different. So don't worry about anybody else's data. Worry about the measurements you got from your blocks, because the ultimate goal of this activity is to choose the 27 best blocks for your puzzle. And by best blocks, we mean the blocks that are closest in size to one another. That way your puzzle pieces fit together properly. And so everybody's data is going to be different. Alright, some numbers that we're interested in are the sum, the average, the minimum value, the maximum value, and the count of our items. And then we also are going to create bins And the way we do that, I'll show you in a second, is if we highlight all of our data here, these are all our measurements, right? So we're highlighting B2 all the way down to B34, okay? And what's cool about this program is I can hit this Explore button, and it gives me some of that data that I'm looking for, right? So my sum, I can actually drag this. If I left click and hold, I can drag this over like that. My sum is actually all my blocks. If I were to line up all my blocks, the sum is the total distance of the blocks. So it's just over 2 feet. I've got my average. That's my average block size. This is my minimum is going to be my smallest block size. My maximum is going to be my largest block size. And then the count A stands for count all. So that's that's all of your items. So in our case, they're blocks. So I have 33 blocks. If you don't have 33, then you've messed up somewhere. You don't have all of your measurements from your blocks. You need to go back and double check that. Alright, so that's an easy way to get that data. Okay. Now that we have that data, we can actually make our bins. So you can think of bins as like categories, alright, or buckets. So let's say we had to sort out a large 5-gallon bucket of screws or bolts or something like that. We could start sorting those out into different buckets by the size of the bolt or the screw or whatever. And that's kind of what we need to do here. So it'll make sense once you see it. So what we want to do is in this first cell after the bins label, should be D2, we're going to type in our minimum value. Okay, so I'm going to Control C there to copy, Control V to paste. Oh, no, I'm not. Let's see here. My minimum. I'm going to right click and copy, right click, paste, and what's going on? Paste values only. Okay, there we go. Alright, and then I'm going to go and get I'm going to look at my maximum value. So my maximum value is 0.758. Okay, so what I want to do is I want to create bins that go by 1/1000th of an inch, right? So 0.745 is my lowest number, and I want to take that and I want to add 1/1000th of an inch, right? But I don't want to go, I don't want to put, 0.746 here, 0.747 here, and do that. I want it to do the work for me. So I'm going to double click here, and I'm going to put equals, and I'm going to click on the cell that I want to add to. So that's D2. Okay, so equals D2, and then I want to add 0.001 because I want to add 1/1000th of an inch to this. And then I press enter, and that gives me my next number. So just like earlier, I can highlight these two, right? And then I can grab the corner and I can drag down, okay? And you might have to drag down a long ways. If your range if the difference between your minimum and maximum is a lot, you might have to drag further than that. Hold on. Okay, I'm sorry. So instead of grabbing both of these, you're going to grab this second one here that we put the formula in. You're going to grab from the bottom, then you're going to drag down, and it'll autofill. At this point, we want to go back to whatever our max value was. So yours is going to be different. Mine's 0.758. So I go up here and I find 0.758 here. It's there. So anything higher than this number, right? So 759 and on. I can highlight that and I can get rid of it because I don't have any blocks that are in this range here. So I highlight it and then I press delete. Okay, so these are my bins. In other words, every single block size that I measured falls within one of these categories here, one of these bins. Okay, this will come in handy later when we make our histogram. Alright, so at this point, we have our block numbers, we have our measurements, we have our bins, and we've got some initial descriptive data here, but we want a little bit more. So, in fact, we want to have a visual representation of our block measurements. So we're going to create what's called a histogram, and we're going to get a few more measurements. So in order to do that, we actually want to grab what we call an add-on. So we're going to go up here to extensions. We're going to go to add-ons, and some of you guys might already have it in here. There's an add-on called Excel Miner Analysis Tool Pack, and I don't have it, so I need to go to add-ons and get add-ons, and then once I get here, there'll be a search bar, and I can put Excel Miner, right, and then it pops up, Excel Miner Analysis Tool Pack. So I want to get that. This is it right here. So I select that and I install, continue, and then I click on allow. I make sure that I'm using my school email, and I allow it to have access, and then I'm done. So now when I close this out and I go to extensions, I've got this add-on right here. Okay, so we're going to stop here, and then I'll start the second half of the video where we create the histogram, and then we get some more descriptive statistics, and then we'll do a little bit of data analysis, and we want to get rid of our outliers because we have 33 blocks that we measured. We only need 27, and we want 27 that are close to the same size, right? So there are 6 of them that we want to get rid of. Those are called outliers. All right, outliers are anything that are outside of the normal range. So for us, we want to get the ones that are furthest away from the average block size, because we want blocks that are close to the same size. That way they'll fit together. All right.